Hello, everybody, and welcome back to Mr. Marlowe's math class. Today we are working on lesson 4 of module 6. This is going to be titled Creating a Histogram. And a histogram is another way, sort of like a dot plot, in which we can organize information that we collect in order to read it and analyze it more efficiently. Okay, you're going to notice that today our lesson looks a little bit different. I'm trying something a little bit new. I wanted to see how this would work out on a PowerPoint instead of me writing it down in my notebook. It might be a little bit easier for you guys to read. So again, Mod 6, Lesson 4, creating a histogram. Our target for today is I can create a frequency histogram. I can explain how the number of intervals affect the shape of the histogram. And I can describe the shape of a histogram as symmetrical or skewed. And we will go over in just a second what those terms mean. So we do have some vocabulary to discuss today. Going back to last week, remember a dot plot is a graph that shows how often a number or category occurs. A histogram is similar, but it's a bar graph where the bars represent a range of scores instead of one number. Okay. An interval is a range of numbers, for example, from 1 to 5, 6 to 10, 11 to 15. Symmetrical means shapes that are the same on both sides. So think of some shapes that are symmetrical, right? Like if I cut a square down the center, both sides of that cut are going to be the same, so they're symmetrical. Your face is symmetrical, right? If I were to make a line going down the center of my face, it's going to be the same more or less on either side. Okay, skewed means to be stretched out and shorter on one side than the other. And the tail, the part of the graph that is stretched out and shorter. So I believe these should have been two separate words, but that's okay. So basically we have skewed, and then we have the tail, right? There we go. That looks better. So the tail is the part of the graph that is stretched out and shorter. And don't worry if you don't know what that means just yet. We will get to it, okay? So how we're going to do this is we're going to look at our table, right? Sort of like what we did with the dot plots. And we want to find out, are more people born in the summertime? All right. So what I did is I went around and I asked a bunch of people. Remember, part of statistics is the ability to gather information. So I went around and I asked a bunch of people what month they were born in. And I want to see if there's a trend or some piece of information that we can gain that'll help us answer the question, are there more people in summer? So I asked a bunch of people. Let's see how many people I asked. I asked 5, 6, 10, 23, 30, 35. I asked 37 people what month they were born in. And now I'm going to write down the results. And I'm going to first write down the results in my tally column. So in January, I found that there were 2 people born in the month of January. And over here, I can write a 2 for the frequency. In February, there was only 1 person born. And over here, I'll write a 1. In March, there were 2 people born that I interviewed. So I'm going to make my tally mark 2. And I'm going to put a 2 right here. Let's see, in April, there was 1 person born out of the 37 that I asked. So I'll put a 1. In May, there were 4 people born. So I'm going to put 4 little hash marks for 4 people. And I'm going to put a 4 over here. In June, there were 6 people born. Including my wife. Her birthday's coming up very soon. Don't let me forget. There were 6 people born. Okay. In July, there were 7 people born out of the 37 that I asked. And if you guys don't know, when I'm making these hash marks, every fifth hash mark, you'll see I put this diagonal line. That diagonal line still means 1, but it's just so we can group that 5. So if I was looking at like a bunch of data, say that included like 15 people, I could just clump those numbers together and read them a lot easier than just counting out individual hash marks. Okay. In August, there were also 7 people born. So I'll put 7 hash marks and I'll write a little 7. Let's see, in September there were 4. In October there were 0. So I'm going to leave this part blank, the tally column blank, but I'm going to put a 0 right there. In November there was 1. And in December there were 2. So already I've taken a list, right? And I've put it into this table, and we can already see some trends, right? Like, look what happens as the weather gets warmer. It looks like more people were born in warmer months. So now what we're going to do is we're going to take this information right here, okay? And we are going to create a histogram. That's the point of today's lesson. We are going to create a histogram. And so just like the dot plot, we have an x and a y axis, right? The y is going to be labeled with the number of people, 1, 2, 3, 4, 5, 6, or 7, because the most I had was 7 in the months of July and August. And then the x-axis is going to be labeled with the months, okay, the month born in, all right? And this is how we create the histogram. Remember, it's going to be bars, not dots. So in January, remember, I found 2 people that were, well, I don't want to use this tool. We had 2 people that were born in January. So we're just going to make a line going up to the 2 and a line going across to show that it represents going all the way to February and a line going down. And now I know I can look at this graph. I can look at January. I can say, oh, there were 2 people born in January. In February, there was only 1 person born. So my line just goes up to the 1. You can see how that corresponds right there, right? In March, there were 2 people born. So again, I'm going to go up to the 2 and then over to April, right? To signify the entire month of March. In April, there was only 1 person again. So I'm just going to put this right at the 1. In May, there were 4 people. So I'm going to take this and I'm going to go all the way up to 4 and I'm going to try to eyeball it and make sure it's okay. That looks pretty good right about there. And I'm going to go over to June and down. In June, there were 6 people. So I can go up to 6. I can go across. And you guys are starting to get the idea, I hope, right? This is our histogram. This is our bar graph. In July, there were 7. I'm going to go up to 7 and over and down. In August, there were 7, so I'm going to go straight across all the way to September and down. In October, there were 0, so I'm going to leave this spot right here blank. And in November, there was 1. And in December, there were 2. Okay? So that's how we make a histogram. Now look, now I can go by and if, maybe Selma says, hey, Mr. Marlowe, in the survey, how many people were born in July? Well, I go over to July and I look and I follow the graph up and then I follow the graph over and I can say, hey, Selma, there were 7 people born in July. And that way I don't have to look back at my list, right? It's a very neat visual that I can use to help me interpret data. Now, the other thing we have to do, right, is we have to discuss the shape of this data. Does this data give us some sort of shape? And you might be thinking to yourself, yeah, maybe not, Mr. Marlowe. I could go either way, and I agree. This data right here, I think, has a shape, but you do kind of got to stretch it. So let's look at what the different shapes are. So this right here is what we call a normal distribution. And you see this word called bell curve, right? Because if I were to take a line and just draw it around my data, the line that I draw, it looks kind of like a bell, right? It looks like a bell you could ring. So they call that a bell curve. And it's symmetrical. Remember what symmetrical means. And it's symmetrical because if I draw a line right down the center, it's more or less even on both sides. So it's a symmetrical distribution or a normal distribution. Now over here, we need to talk about things that are skewed, right? So if I were to try to draw a bell around this, I couldn't, right? I couldn't draw a nice bell, but I could draw a line like that, right? And this would be a graph that is skewed to the right. And it's skewed to the right because the tail of the graph, right? Think about what a tail is, like the tail of a mouse. It gets skinny, right? The tail points to the right. This graph over here, if I were to draw a line, that graph is skewed left because the tail trails off to the left. Okay, so if we go back to this graph right here, right, I could probably draw a line something like this. Now notice like right here, it doesn't quite fit. That's okay. One thing you guys are going to learn about statistics, actually I have a good friend who once described statistics as fuzzy math. Okay, it's not like the math that we've been doing where you get a nice clean answer all the time. Sometimes things don't fit perfectly, and that's okay because we're taking data from the real world, and data from the real world doesn't always fit perfectly. So I would say this maybe trails. This is skewed left maybe a little bit. It's not. If I were to try to draw a line straight down, I wouldn't say that that's perfectly symmetrical, but it's getting there. I would say it's normal-ish, okay? So let's see what happens to our graph, right? If we do frequency by season. So remember up here, we did bursts by months, but now we're going to lump these together. So we're going to lump them, let's see, it's in groups of 3, okay? So we're going to have December, January, February, the winter months, and then the spring months, and the summer months, and the fall months. And let's see what happens to our graph when we organize our data this way. So let's look at January, February, and December, January, and February. So remember I had 2 in, oh, you know what I'm going to do? I'm just going to write down. I had 2 births in December, 2 in January, and 1 in February. So it's a total of 5. Okay. And March, April, and May, well, I had 2 in March, 1 in April, 4 in May. So that's a total of 7. June, July, and August, I had 6 in June, 7 in July, 7 in August. So let's see, that's 13 plus 7, that's 20, right? And then September, October, November, well, I had 4 in September, 0 on October, and 1 in November. So that's 5. Okay, and I want you to just take a second and just think about how this graph is going to look different from the previous one. Do you think it's going to look more symmetrical? Do you think it's going to look less symmetrical? Do you think it's going to look about the same? What happens as we consolidate these tallies that we took. So here we go. All right. We have in winter, right? We had, where's my little tool that I want? In winter, we had 5 births. So I'm going to go up to the 5 and over to spring. In spring, we had 7. In summer, we had we had 20. We could make this go up off the page for 20. Right? And in fall, we had 5. So you're gonna have to use your imagination here, right? We could say that this is 10 right here, right? And then it's gonna go up 20. It's gonna go up another 10 because we had so many births, right? So now let's think about this graph. Does this look a little bit more symmetrical? Why? Right? What happened when we consolidated our information? Does it look a little bit more, and again, I'm going to have to go off the page, does it look a little bit more like that nice bell curve? Yeah, it does. So as we consolidated that information, right, the graph itself became more symmetrical. All right, so here's a quick check, okay? Remember that our normal distribution is one that's symmetrical. If I draw a line, right, the graph is symmetrical on either side. A graph that is skewed to the left is one where if I draw a line that follows the data, it's one that the data trails off to the left, like a tail. And if the data is skewed right, it's one in which the tail trails off to the right. Okay, so what is an interval? This is the last thing we have to talk about, all right? Remember, if we go back to our vocabulary, an interval is a range of numbers, for example, 1 to 5, 6 to 10, or 11 to 15, okay? Right here. All right, that's our definition for interval. It's a range of numbers. So, if we look at this table, right, our first interval is 5 to 10. And if we notice on our histogram, that first block goes from 5 to 10. And the frequency in that interval, within that interval, is 1. So you notice the block goes up to 1. Okay. Our second interval is 10 to 15. And if we notice back on our histogram, the second block goes from 10 to 15. Okay? And within that interval, there's a frequency of 2. Our third interval is 15 to 20. 15 to 20. Within that interval, our frequency is 4, so it goes up to 4. The fourth interval is 20 to 25. We notice that our frequency is 0, so there's no bar at all there. 25 to 30, right? That's our, that would be our 6th interval. 1, 2, 3, 4. I'm sorry, our 5th interval, right? And that has a frequency of 3. Our 6th interval is 30 to 35, right? And that has a frequency of 5. And our final interval is 35 to 40, which has a frequency of 6. Okay, so that's what an interval is. It's just how far the distance covered by the bar, okay? The distance covered by each bar. So if we went back up to our original histogram, right, our interval would be 1 month. Or maybe you could just say 1 if we know we're talking about months, right? So our interval is 1 month. Each one of these bars covers a span of 1 month, so the interval is 1 month. So wrapping it up, frequency histograms are a way to visualize or see the data. It's a way for us to really grasp what's going on. Histograms have a certain shape that can be described using words such as symmetrical or skewed. And changing the size of the intervals in the histogram changes the shape and gives you different information. Remember we had, if we look at our two histograms, when we changed the size of the interval, from here we went to 1, right? And this was our shape. The shape was kind of wonky a little bit. And then we went to intervals of 3, and the shape sort of normalized, right? So that's it for today. Changing the size of the intervals in the histogram changes the shape and gives you different information. Sorry this video was a little bit long. I hope you found it useful. If you have any questions, reach out and I will be here to answer them as best I can. Thank you very much and have a great day.